thank you everybody for joining today's session. This is our second guest speaker for the August series of safety guest speakers. Today we're going to be discussing unsafe information leakage in safe AI responses. And it's going to be presented by our speaker, David Glukhov, who is a PhD student at the University of Toronto. So just some background about David. He is a second-year PhD student supervised by Nicolas Papernot and Vardan Papyan at the University of Toronto. He is interested in the formalization of desiderata of secure and reliable generative AI, or in other words, how to formally define and guarantee properties that make Gen AI trustworthy, safe, reliable, robust, and aligned with human values. He studies the limits of today's safety methods for LLMs, and he's had many works showing why approaches like censorship and filtering often break down in practice. And his work has also developed new ways to understand and measure when models leak sensitive information, as he'll be discussing today, and as well as techniques that combine differential privacy and general robustness to adversarial attacks. So most recently, he's explored this kind of idea of how unsafe information can be leaked in safe AI responses. But I'll pass it over to David, maybe to continue on and kind of discuss his presentation for today.
Okay, great. Thank you for the introduction. Let me see if I can share screen. I think it's loading very slowly. But I guess I can kind of quickly, in the meantime, give an overview or background. Is that very frequently when we're dealing with, like, let's say an LLM or interacting with it, there is often like a concern that, okay, if I ask it directly, it's going to refuse. If I try to engineer my prompt, maybe I can bypass it. Maybe I can engineer my way out of this as a failing mechanism. However, at the same time, there seems to be a lot of these incidents where, like, you might make I don't know, some indirect kind of question or line of reasoning, and you actually end up getting like information that could be used problematically. So like sometimes this is referred to as dual use application. I don't know why my browser is like, okay, struggling with screen share.
You might need to maybe leave and join again. Oftentimes that might help.
Okay, I might do that. Oh. Wait.
Is it just taking a while to?
Yeah, I think okay. I think this should.
Okay.
Can everybody see?
Yep.
Okay. Yeah. So yeah, I'm David, University of Toronto vector, and so kind of there's this dual use component, and I think I found it to be very understudied within the field of AI safety, and so kind of within this talk, I'll discuss basically what are the gaps in the way that we currently assess risks and mitigate them for a lot of generative AI, specifically LLMs, but I think a lot of these principles will also apply to things like image generative models as well. So I'll discuss essentially jailbreak free. So jailbreaking here is when you kind of try to engineer your prompt in order to get a specific bad outcome. So jailbreak free type of attack, which is exploiting this kind of dual use property I just mentioned, which is like you can kind of still learn something problematic. And I actually will formalize this through an information theoretic threat model. And so from this, we can get very nice evaluation methods, or at least interpretable evaluation methods, guarantees of like what it means to guarantee safety against these types of adversaries, and also understand like formally what are the utility trade-offs that will be incurred by providing such a defense. So okay, as overview, I don't know generally how familiar, maybe we can go through this relatively quickly, but there's a lot of risks or concerns that people have. So one is just from security. It's like this is now a new attack vector. Somebody could kind of abuse it to get, I don't know, like refunds from a chatbot. It can be used to generate deepfakes, to spread misinformation, this was like a major concern in that there was like a White House agreement and so on. There was lowering the barrier to entry for various like radiological, chemical, biological cyber weaponry. So anything that can really kind of threaten on like a large scale, safety of individuals. There's also kind of, this is a legal and a PR exposure issue from like problematic outputs that like now somebody can kind of be like, oh, to a company like, look what your chatbot said. So this is kind of, I think, probably still a concern from the perspective of a company. And then there's also the misaligned agents, which is more maybe sometimes existential risk related. And so I'd say that like this talk is not really focused with this issue. However, the underlying ideas that we presented could be still very relevant to this type of risk. So major challenges. So one of the ways that people typically approach, or actually the main way that everyone is approaching risk assessment, is through red teaming. So red teaming is essentially, there is some entity that is using some adversarial method to assess the model's ability to produce like a problematic output. And this is often used to evaluate defenses. The problem that so far has been kind of identified is that this has been like a classical paradigm and approach in classical like computer security. However, as it's been currently applied to generative AI, I mean, there's been criticism essentially. So the goals are not actually very well defined. So there's no very like, there are some inconsistent kind of definitions of what is considered problematic, what is considered unsafe, but there's no real like standardization. And even those definitions are not usually extremely well scoped. They're very much like human judgment type of setting, and maybe not even a priori defined. There's basically a large variability in the methods, in what is considered bad. There's no standards for any of these, like the attack defense evaluation settings. So kind of every new instance kind of, I mean, there's like within the research community, sometimes there's just like building off of prior stuff, but on like a very larger, broader scale, this is like, there's never been really a clear established protocol for how to approach each of these things, and they kind of evolve very rapidly. And again, the threat models of like, what capabilities do we assume the adversary has? What are their limitations? What are the defenses? What are like, those things are not often really clearly actually articulated or like formalized. And also just very high level is that the values and essentially like who is doing this red teaming and who determines like what is bad is not something that's really been addressed. And it's seemingly largely led by basically like corporations, which are saying like, oh, we would consider this bad and this not bad. And like, it's very Silicon Valley kind of isolated. And so, yeah, like basically the values is something very important to consider. So, okay, how do people actually think about the attacks? So there's kind of three main, let's say, classes currently. There's prompt injection, which is essentially you're going to have some application that is using an LLM. And this application, let's say like an email assistant, it may read something which is like viewed as a trusted input. And that trusted input actually had some harmful instructions attached to it. And these override the LLM's intended behavior. There is jailbreaking, which is like kind of, these are interrelated essentially, but jailbreaking is usually specifically that a person is engineering a prompt directly to bypass some built-in safety mechanisms of an LLM. So they are attacking the model directly. They're not attacking an application using the LLM. And then there's manual red teaming, which is humans are attempting to complete tasks, which involve this sort of impermissible information synthesis. So there's been some evaluations where they were like, okay, here's things that are like dangerous. Here's a person with access to Google. Here's a person with access to an LLM. Let's see what they can do. And so kind of the way that a lot of attacks are even sort of designed is usually you append some tokens or basically some string to a prompt that is requesting something malicious. And this essentially breaks whatever is the intended behavior of the LLM, and it kind of just agrees and complies with the malicious instruction. But the key kind of often evaluation here is basically just whether or not the model complied, not some functional property. And so kind of based on this type of perspective or approach, the way people think about defenses is this is sort of like an all-encompassing, I think. My impression is currently you have an input, there is some filters that can basically try to detect like, oh, is this problematic? Is this not problematic? So kind of do some classification, look at the perplexity. So it's like how random is this input text? There would be a system prompt usually added that's trying to steer the model toward like some good behavior. There can be various safety alignment methods. So this would be like various methods for fine tuning, like RLHF, unlearning attempts. And so then also you can kind of apply a lot of these things to the outputs as well, especially because a lot of the problematic and permissibility is usually looked at from the output level. So from that perspective, here's kind of a potential alternative attack. So we can always say, like, okay, what if we were to ask an LLM directly, like, write me some ransomware? And it's like the ransomware consists usually of like, you have to read some data from a disk, you have to encrypt it, override those contents. There's a bunch of other things, but these are like some key components. So the LLM, if you ask it directly, like the LLM will just say no because of all of these safety mechanisms built in. But I could ask, well, just write me some code that reads data from a disk. Okay, sure. It's like, that's fine. Write me a file or like a code that encrypts data. Oh, okay, sure. That's on its own. That's fine. Like these are asked in separate contexts. Write me some code that will override the, like a disk contents with just like another file. Like, sure. I mean, this is still normal. Again, in a separate context. The problem is that combined these code, like these outputs, code could be essentially put in together into ransomware. And so this is sort of, nothing here relied on a jailbreak. There was no engineering to try to force an LLM to produce specific output or try to break like an existing defense mechanism. I mean, this here LLM is just like wrapped all with all of these filters and guidance. But the problem is that you still get something bad. And so the question is like, what is happening here? How do we understand this type of threat? And so I think to sort of better even understand or distinguish what's going on, we can actually identify at least two different adversaries in terms of their objectives. So the classical perspective that people have adopted is sort of this I would call security adversary. So security adversary is directly attacking the model or the system. They already have an idea of what output they want from the model. So basically an adversary succeeds if the output of the model belongs to a set that the adversary considers good, that like is a set of bad outputs. And so this is assuming this sort of explicit knowledge and characterization of what's impermissible and things that even like classical adversarial examples in image classification, you could identify it's just it misclassifies or prompt injection. This is like the typical jailbreaking attacks. They fall under this family. The alternative family, which is sort of going back to the previous example, is an inferential adversary. So this adversary, they have some prior belief about an answer to a question that they have. So they have some, let's say, malicious or problematic question, and they have some belief of like what might be the answer, but they're not really sure. They don't really know. They're very uncertain. And so what they really want is they actually just want to get knowledge from the model. They want to learn something. And so they don't actually have a characterization of like what is a good, like what is the correct output and what's not the correct. Like there's no like the model produced a bad output. It's sort of the model produced an output that actually helped me learn something that I wanted, let's say, or just learn something. And this is a lot more similar to what classically would be like model extraction attacks. So when you're trying to extract the parameters of a model, or like privacy attacks, where you're trying to understand or extract what training data belong to the model. And so in both of these settings, again, you don't have the characterization of the truth. You don't have like a ground truth kind of success. Yeah. Now, essentially what we're studying is compositional, or like what we study in our work is compositional and dual use threats, which are falling really within this, I would say, compositional inferential adversary. So these are adversaries which are aggregating safe, quote unquote, safe answers, because on their own, they're not inherently problematic or wouldn't be deemed as such, let's say. And they aggregate this into something that is unsafe. So you might have like, oh, how do I scam somebody? That's like impermissible on its own. But there's a lot of questions which, I mean, maybe they're like somewhat weird, but they're not inherently bad, and they're dual use. Somebody could be asking these questions for a clearly like beneficial reason. It's not actually clear from the context or lack thereof provided. But the problem is that the answers to these questions could still really inform an adversary about the kind of hidden impermissible question that they have. And so the way that we can kind of instantiate this, or the way that we instantiate it, or at least there's many ways, we typically would have like an adversary LLM and a victim LLM. So the adversary LLM has a query queue, like some malicious query, and they have some interaction, which is basically how many times can they interact with the victim, and like some few shot examples that are sort of helping clarify what their functionality is. And so the desired output is basically an answer to the query. Now, the key thing here is that the answer that will be outputted is not going to be an output of the victim LLM. Instead, it would actually be an output of the adversary LLM based on knowledge it acquired by interacting with the victim. So you would create, like the way you instantiate is like you create a knowledge pile, usually just empty, let's say. The adversary LLM is instructed to generate some sub-questions related to the query. These sub-questions are in independent context submitted to a victim LLM. That question undergoes input filters. The victim LLM answers it, and then it undergoes like an output filter. This answer is processed by the adversary LLM to extract whatever context it deems relevant to the malicious query. And then this is compiled or like basically concatenated to the knowledge pile of the adversary. And at the very end, the adversary returns an answer to the original kind of problematic query that it was given, based on the knowledge it has acquired by interacting with the victim. So, okay, how do we actually think about like, what do we evaluate? Because typically everything has been, I have a victim model, I probe it with questions, I try to break it, and it produces an answer, and that answer is problematic because some other LLM told me so, or because a human evaluated as such. In this scenario, I mean, the adversary is the one that's answering the question, and so we need to figure out like, well, what's the marginal risk? Like, what did the adversary actually gain by talking with the victim LLM that it wouldn't have had to begin with? And in a very general setting, I think this is hard to evaluate. In the multiple choice settings, so for example, there's this weapons of mass destruction proxy benchmark, which is a proxy for what kind of malicious knowledge an LLM has that is like relevant to things like cyber, chemical, or biological threats. And so these are multiple choice questions, and we can actually now look at, well, what is the adversary's belief in the correct answer before and after interacting with the victim? So in order to do this, we filtered a bunch of these questions to be those that would actually be filtered, like flagged as impermissible, because by default, some of the questions are not like, they're not inherently necessarily bad as well, because they didn't want to reveal too much information. But there are some that, let's say, would be more problematic. And so we filter those. So this way we have like an actual defense mechanism that's working for the victim LLM. And so we have this metric for essentially what information the adversary gained. And so this metric would be like, it's very kind of like information theoretic, but it's basically like the posterior, like what's the belief after learning, divided by what it was before, weighted by the after belief, because it's sort of, if the adversary is still unconfident after learning some stuff, then it's not necessarily very problematic. And so like the adversary might start off kind of uniform distribution. They interact with a bit more, they get more information, they interact a lot more, they get a lot more information, assuming that, again, the answer is C. And so then we can evaluate this essentially we have like various victim models. These are like some fine-tuned. This was an unlearning fine-tuned. This was like safety fine-tuned, llama versions. And so we can kind of compare it to like a jailbreak attack, or a jailbreak is explicitly trying to kind of construct these jailbreaks in an iterative, refined manner. And then basically based on whatever answer is actually like, let's say, passes the filters and provided by the LLM, and deemed relevant to the original query, that's like just the knowledge pile, let's say, for the adversary. And so the problem was that, like, if you try to do the direct jailbreaking, essentially you get caught by either the input and output filters. So there would be like llama guard and shield gamma, which were just stacking both of them because, like, why not have stronger defenses? Or just because like an LLM refused to essentially answer the question on its own. Whereas the decomposition, like, the questions that it would ask often, they're sub questions which on their own, again, are essentially less problematic and less likely to be flagged. So usually we're able to extract actually more information. And also it was leveraging like a compositional aspect, because it was actually able to leverage the fact that multiple answers can jointly help inform. Okay, so moving from like, this is the adversary, this is kind of the way we can think about like, how do we do this attack? And how do we understand kind of the adversary model in general from this inferential adversary setting? How do we actually define like defenses, or like what is a safety guarantee in this scenario? And so you can actually, as like an information censorship mechanism would be like a mechanism that will guarantee safety. And essentially is going to be based on bounding compositional information leakage, which if you don't have any of the prior context of what questions were being asked is very difficult. So you typically bound individual, like information leakage of any individual query, which actually gives you an upper bound on the compositional information leakage that somebody can have. So we'll kind of go a bit into more detail of what that means. However, I will say, like, constructing a practical mechanism for this, I think, is going to be a very challenging problem, and would likely require things like evaluating information leakage and information gain. Those are very difficult. And then after that, we'll discuss essentially there's actually provable safety utility trade-off that if you were to have a safety guarantee, there would be actually trade-offs and losses of utility, unless there's essentially like a lot of this, like the knowledge is very well separated from like the harmful from the useful. And yeah. So how do we actually define information censorship? What is it? So the idea is that we want to cap the adversary's expected gain in belief over impermissible answers given any interaction history. So we assume a prior over like the adversary. So what prior belief does the adversary have? What knowledge do they already have to begin with? And based on that knowledge, like if they were given this problematic query, they'd have already a belief over what answers are possible. So it's like if the adversary already knows like the problematic answer to a problematic query, then like the victim LLM doesn't really, like there's no risk really associated because the risk has already been exposed. Like an adversary that would be using an adversarial LLM in this context, like they wouldn't even need the victim LLM. And so the adversarial LLM here can literally just be like an open source, open weights model that's kind of just publicly available. There's many of these. And so, okay, so if we have a censorship mechanism, we'd say that the censorship mechanism would look at both the input and the model output. And from that, it would kind of produce an answer. So like the final answer to be returned to the adversary. And so then we're essentially looking at like how much information that's specifically problematic that the adversary gained. And by specifically problematic, it's like, what's the probability that their belief in a bad answer, so to the query, there could be a set of good answers that are like benign, and there could be a set of bad answers, which bad here is not like low quality, but actually high quality in a problematic sense. And so it's specifically like the same as this evaluation metric, how much did the adversary's belief increase relative to what it was before? And then essentially weighted by what's the probability that the adversary is like gets these sort of responses from the victim LLM with the censorship mechanism. So overall, making sure that it doesn't gain confidence in something problematic. And so kind of from this, we would say that a safety guarantee would be that we've actually bounded this entire like possible information gain over the possible adversaries that we're considering and their priors, and the possible questions we are concerned about. So I think this is like very difficult to kind of provide in practice, but there could be feature work that kind of help make this a bit more realistic, or yeah, like kind of practical, or some kind of methods inspired by this. But the point actually to me that was interesting is that we can actually use this to gain insight into essentially how would we actually lose utility for a benign user based on providing such a guarantee. And so for me, this is, I think, like a very significant conclusion, because this has sort of been, heuristically, there's been some claims that like, oh, the moment these models are like RLHF'd into safety, they become bad and they're not useful anymore. And then there's other claims which are sort of saying that, oh, actually, like safety and usefulness are perfectly compatible and they'll kind of benefit each other. And so my point is actually that if you were to assume this type of threat model where the adversary is just trying to learn something that could be problematic, or that is problematic, you actually will have to restrict how much a benign user could learn about something which isn't problematic. And the reason, again, is because of this dual use. So like a farmer that might be very interested in learning about sourcing, I don't know, fertilizer is not going to be able to get a lot of information from an LLM, because that fertilizer could also, like that information could be helpful for somebody that's trying to make like a weapon or like a bomb, explosive, something. Or I don't know, like somebody that's trying to learn about like safe preparation of cassava would not be told this information, because that would like maybe help them learn how to extract some poison. Or even like cybersecurity, it's going to be like difficult to do white hat hacking with using an LLM, because again, this could be used adversarially just without having provided this overall context. So the key here, by the way, is also the fact that all of these queries, they can be submitted to models in separate contexts from separate accounts. It's very difficult to actually track what is the intent behind the user asking the question. And so, yeah, we can bound this. This is kind of a maybe unclear, messy formula, but the kind of key takeaway is that the utility can really only be preserved when the useful knowledge isn't entangled with harmful knowledge. And specifically, it's that like it doesn't inform the harmful knowledge, that like provided this, you're not going to gain a lot of information about the thing that's problematic. Or there is another possibility, is if you have maybe some really good defense mechanism, or like a adversary kind of that isn't confident in like this is definitely not the correct thing, it could also still preserve utility if essentially it convinces an adversary into becoming confident in some permissible belief. So like as long as the adversary could gain information, but they'd gain information about like a non-problematic answer. I think both of these mechanisms, like they become very difficult to like instantiate. So sort of the overall still idea is that like you will have actually a bound on how much utility a benign person can get. So yeah, overall kind of conclusion, message, takeaways, there is the ability to compose responses from LLMs that are kind of on their own independently benign, but together they actually do inform an adversary about unsafe knowledge. And so this allows someone to even kind of extract information from a model that was perfectly robust against jailbreaks. Jailbreaks would only kind of assist or accelerate this because they'll just more directly provide that information. The current defenses that we have, they don't really address this ability to aggregate responses over multiple interactions. So this would most likely require things like very careful user monitoring, extensive like context modeling of like all of the interactions the user had. You might need to have like single, like, I don't know, like an ID to log in or something. So it's like, But even then, like a lot of this stuff it's going to be very difficult to sort of perfectly ensure defense there. If you wanted to, from like a very kind of mathematical way to provide a safety guarantee, there is a way that you can actually formulate this as like a criterion, like what needs to be done. And like this does incur explicit utility trade-offs. If people are interested in like a mechanism kind of that intuitively can help understand like what would provide this type of guarantee, like how would someone design such a mechanism, the simplest way you can think about it is you would have a model that based on the amount of information a given question would potentially leak, they would probabilistically just output nothing. And so essentially, if you assume that the adversary only has a bounded number of questions that they can ask, they only ask like K questions, well, then if each question is something very risky, basically they'll never get an output. And this also makes it very clear why like there's going to be a utility trade-off. And so, yeah, and then basically the open challenge is like, can we actually kind of create censorship mechanisms that are practical, might still provide like a guarantee of some form, maybe weaken the types of guarantees or redefine them, or just help provide like utility trade-offs. Also, again, because there is sort of now an evaluation approach, this can be used for kind of studying and evaluating these mechanisms, even if they're not necessarily providing like an explicit guarantee, which would be definitely ideal. So these are my collaborators whom I worked with for the project. I'm very much open to discussion, and like if there's people who have any questions, I can expand on a lot of things that I've presented so far. So yeah, let me know.
Thank you so much, David, for the awesome presentations. Yeah, we'll open up for questions now. So looks like one person has raised their hand. Feel free to unmute or ask your question.
Okay. So thank you for the wonderful talk. One question I had was, so let me give you the anecdote of what happened. So when Google and Facebook and stuff, they were all like, we're gonna rent out entire areas for our like nuclear power, like through what's like, I think they wanted to use these portable units, these I think it's called like SMRs, small modular reactors. And so I go to Claude and I'm like, okay, so how concerned should I be that these like companies are trying to like amass nuclear technology? How easy is it to go from an SMR to like a nuclear weapon? And it refused entirely to like touch the subject, which I thought, which like, and even if I clarified and I was like, listen, I don't want you to tell me like how you would do it. I'm asking like about the feasibility given the resources of like said company. And again, it refused to do it. It even mentioned dual use technology to me. And when I asked like, what is dual use technology? It again completely shut down. So in one sense, I can see the benefit of, like rejecting the response like completely and rejecting giving any information. But on the other hand, from like a societal safety standpoint, I can also see how this could actually be quite dangerous if people don't know, like how to, don't know like the risks that might be like amassed by set companies towards an actual existential risk. And I still like struggle to think about like how you would like disentangle these two things, given the fact that like people can ask things in a very benign or like innocent way and try to get out like quite damaging information or harmful information. I was wondering if you've given it any thought, or if like if there's discussions, etc.
Yeah. My like really big kind of belief in this regard is there needs to be in general way more emphasis and care in actually defining what is deemed problematic and what isn't. So within this kind of talk, I've left that basically untouched. So the way that I was essentially defining everything would be to say, there is a finite possible set of inputs that go into the model. There's a finite possible set of outputs from the model, just because the context lengths are always finite. And like, you would have somebody that says there's subset of answers and like corresponding with this subset of questions, like this is bad. And a huge missing gap here is actually defining what does bad mean. And I think this has been largely kind of open to interpretation by a big company. And there's no, like, I haven't seen any efforts of very carefully from like some first principles trying to establish what is bad, what isn't bad. And I think especially what happens when like a lot of this fine tuning or like safety filters are put into place, it becomes even more detached from like a principle. And it essentially will default to being like, if this word was used, then don't say anything. So it could be as simple as like the word weapon would just always offset and like trigger the model. And the model would essentially always default of not saying anything. And so, yeah, sometimes like it can be really almost a syntactic level. And so this is also somewhat like jailbreaks can kind of exploit this. But I think like the other is that once you've even started to define what is bad and what isn't bad, the next step from also this composition inferential stuff is to understand like, yeah, like it's kind of like what inferences are bad and like how are these things actually interrelated? So how useful would it actually be? Like what is actually the bottleneck essentially? This was a thing I think I've heard from like a collaborator, which is like, in regards to nuclear weapon risk, really a lot of the information is not like completely like no one can ever know how to make a nuclear weapon. There is a key bottleneck, which is like you need a specific like isotope of plutonium or something. And unless you have that, like unless you get access to that specific thing, like you're not going to get anywhere. You're not going to like make a bomb. And so as long as like this one key bottleneck is actually isolated and very carefully monitored, then like most of the actual entire threat is sort of eliminated. And this actually might be one of the ways toward like a practical defense, is that you can provide that same guarantee of like bounding this information leakage without any utility almost trade-off, without like any benign stuff, if you can actually identify what is like an informational bottleneck, where like this is a fact that we cannot just derive, let's say, on our own. And let's say, assuming that the adversary didn't already know this information, which might be in some cases a reasonable assumption, basically say that as long as we keep this thing protected and no information about this is revealed, then like essentially everything else can be and sort of safely revealed, which does still provide a lot of utility to individuals. Again, a lot of these things to me are not technical almost issues. Like the technical framework is sort of what we've created in this work, but the actual core of these issues is like a philosophical, like sociological effort that I don't think is, as I've really seen it, for the most part, a lot of the safety community and work that I've seen is more focused on like technical methods and engineering methods, which are very going to be like heuristic proxies. Is that like addressing the question that you're asking?
Yeah, I think so. Thank you so much.
Okay. Thank you for the question.
Yeah, just want to quickly follow up on that as well. I think exactly what along the lines of what you're saying. A lot of people on, I guess I would define this as a spectrum where a lot of people are on one side where they say we want like maximally safe models. And if you take that to an extreme, it's just, you can say like a model that outputs nothing, like it's pretty safe. And on the other side is like a maximally, I guess, helpful model, which is like completely uncensored. And there seems to be a lot of push for that. If you go on like forums or Reddit, like people are generally pretty upset when a big company releases a model that does like really well on benchmarks, and then like a week later, it's like a diluted version that isn't as well performing or isn't as uncensored. And so people on that side, at least to me, it seems the argument they're making is like information is already readily available. Like before LLMs, we had the internet, and you could, in the exact same way you're describing, compositionally like Google specific questions like, how do I get plutonium, or how do I put things together in this way? And you would get the information. Of course, the barrier is much higher, but how would you respond to that sort of argument in terms of, why this is more of a risk?
Yeah, this is actually, I guess, a very common question I've gotten, and so maybe I should have included it within slides. But essentially, I think the main distinction is, in order to get a lot of this type of information from Google, the person that is doing the Googling would usually need to already have a pretty strong background understanding. So in order to learn, I don't know, how to create a virus or something, or some biological threat, if you wanted to do this through Google, you essentially would have to read papers, and you'd have to be able to understand what's relevant in those papers, and you'd need a very advanced background. An LLM, again, the perspective that I think can be kind of nice is just thinking them as a very advanced version of a search engine that not only finds information for you, but it also digests it and provides it in a somewhat contextually relevant way. And so yes, this threat existed with Google, and I think there was degrees of practical mitigation efforts there, but it's way more dangerous and risky potentially with an LLM framework. At the same time, I think that there are concerns that might be overstated, in the sense that, for example, the bottleneck for some biological threat design might not actually be an informational one. It might be access to a wet lab with very all of the necessary tools and all of the lab experience necessary to actually do something. And it could be that the level of knowledge and experience required for that, at that point, the person basically could have already been able to more or less figure it out on their own with Google. So again, this is why I think it's very important to actually define what are the threats, what do you actually assume, what the adversary can do, can't do. I think cybersecurity settings are probably the most concerning, in that they would require potentially the least level of knowledge or expertise from the adversary. And the LLM can actually directly provide code that could be then kind of spliced together to produce something problematic. And that, I think, is sort of this more tangible risk.
And just
Google would not give you, you'll not be able to find, I think, as easily all of these code segments potentially through Google, not as directly.
And in terms of people who are more arguing for this uncensored models in general, do you think that this is kind of it sounds like it's the most common, but do you think it's the strongest argument on that side, if you have to kind of steel man their case?
You mean the strongest argument that they should be uncensored, or?
Yes.
Wait, sorry, what would be the related to the work, or related to something I said?
Yeah, related to kind of in terms of what you were saying about, this is already a problem in terms of Google search engines, and it's kind of an issue that has always existed. But it sounds like your argument against that is the barrier to information.
Yeah. I do think for things like cyber, I think it would be easier without an LLM. Again, it's really just, I don't really have this distinction of harmful versus helpful. It's useful, and it could be useful for something good, it could be useful for something bad. The more useful they get, the more useful they go both ways. It could be that some safety evaluations of saying oh, this is now actually usefully dangerous, is also really a demonstration of the model is useful. And I think a lot of people also start really just associating these two things together. It's if it's useful for something bad, then it's useful in general. It means it's actually good.
Yeah.
I don't know per se if for most of the things that people are trying to use the models for, if the types of safety filtering that is employed is actually the cause of less useful models from their perspective. If the model is a week later after release less useful, it doesn't necessarily mean that it's because it's more censored. It could be just you're getting a cheaper version of the model being served to you. So it's we don't really have this very clearly disentangled. And I don't know. Maybe it depends on how depends on what they're defining as problematic. I guess from the business perspective, like they serve whatever they want. The user, like if the user doesn't like it, they can not use it. They can go use some other model. Yeah, I don't know. I do think one thing that could be an argument kind of in support somewhat is that we like the framework that we kind of describe in this work is it does give you an ability to evaluate like marginal risk. So if you have a like open weight LLM that kind of already captures that entire thing, then like the fact that you're serving it from like a closed, like you're serving, I don't know, like some GPT, like this may not actually have as big of a marginal risk, because like that knowledge is already easily available to an adversary that would be interested. And so that might be something that could be used to like kind of lessen some degree of the utility stuff. But again, in my opinion, like all of this really boils down to the main thing is actually defining what is an actual tangible threat. So like a model that just says, sure, here's how to build a bomb, and then just spits out nonsense is not like a tangible threat, I would say. But again, that's like the discussion that needs to be kind of done and standardized, I think.
Cool, awesome. Do we have any more questions from the audience for David? Yeah. So we have 2 more questions. Go ahead, Taha.
Yeah, hello. So, David, my question is that during this multi-interaction, if we are giving, the previous conversations to the LLM, how effectively does the alignment kick in? Does it any point it kind of, it clicks that, okay, this is a harmful. So have you explored in quantifying that direction, that how well we behave there?
So you mean when the adversary LLM is going to be like, I'm stopping basically?
Yeah, so when it sees it, when we are giving it the chat history along and it sees that, okay, this conversation is going somewhere else.
Yeah, I mean, we compared 2 adversaries in the actual paper. We compared like 2 different adversaries. There was the Mistral, like I think older Mistral model, like essentially they were uncensored. Like they did not have a lot of safety tuning. And so they don't really refuse a whole lot. And like a Llama 2 model, I believe, or maybe a small Llama 3 model. And I think I didn't observe, or there was very few cases that I observed that the Llama 3 model actually started refusing. When it was actually, no, maybe it wasn't that uncommon, but there was, I forget the exact number, but like it would, like sometimes the adversary would actually refuse. But I think in practice, this is sort of like people will and can fine tune this behavior out of models. And so like there is some efforts, I believe, that are focused on how do we like unlearn stuff such that it cannot be fine-tuned back in. But I think this will be much harder to do when it's like not just like knowledge, but just general, like any in compliance behavior. So yeah, like with practical models, there's going to be models that will work better. There will be models that will work worse. But like I imagine from an adversary perspective, like there will be open weight models that will be available that would be relatively like non-refusal. Although maybe that could be an avenue. It could be an avenue, but it's sort of people could still end up being like human adversaries. It's just easier to evaluate as if it's an LLM, but I think human is like typically going to be much better even learning and knowing how to decompose these questions in general.
Okay, thanks.
Okay, and I think we have 1 more question from Bakunga. Go ahead.
Yeah. Hi. Thank you for taking my hand. So my question is more along the lines of multilinguality, especially in regards to, I think Gemini just recently, I was talking to it in a low resource language, and what they've kind of defaulted to is they will outright refuse to respond in a language that is not amongst the high resource or the ones that they've kind of identified. And I think that that's kind of like an area that we've all agreed that maybe that's where the models are most vulnerable. Do you have any sort of like recommendations, or did you actually look at that in the research?
We didn't look at it in the sense like the benchmark and everything that we're looking is just like it's all English language, I think, benchmark. I'm not even sure. I think there might be some works that explore like a multilingual jailbreaking ability. I don't actually necessarily know if it's like 100% always going to be easier to jailbreak in like a low resource language than not. And it's also not clear to me that like if there is a language that's very low resource and like there are very little training data, the actual quality and usefulness of model outputs could also be just lower. So they might be like more likely to agree, for example, but it's also not clear to me how like high quality the responses are, because again, it's like I don't see why whatever its capability is in one language like English would fully transfer to another language that it had a lot less training data in. So like that to me is actually something I'm unsure about, and it could be quite interesting actually to see like what really is the level of like transferability and almost just generally usefulness in the multilingual nature. Yeah, I mean, I would hope that they're not going to just default to a policy where it's like we'll only support one language because every other language is unsafe or something. That would be really bad. But I guess, yeah, like various filtering mechanisms and so on might not be tuned. Like if they're training like RLHF, they were only going to have this type of data in maybe one language. And like, yeah, or like if they're trying to classify whether something is bad or not, like they might have only defined their data set in one language, and like the classifier will only be effective in that one language. So I have no clue.
All right, thank you.
Okay. Do we have any more final questions from the audience? Okay, cool. Yeah, if it's okay, we can end off. I always like to ask this question at the end of our safety sessions, which is if you had $1 million from maybe one of the frontier labs to kind of begin addressing this problem to make sure like 5 years from now we have better results, how would you allocate that money?
I mean, it's like there's not like I'm gonna give money to a specific whatever. Like to me, I think the main thing is having some international effort on actually defining and outlining like standards for what is going to be considered unsafe and what isn't going to be considered unsafe. And this is like not even from the technical perspective, but just having like an actual agreed upon like definition and understanding of what we consider problematic with like extensive justifications. And then after that, the main effort be like understanding these deeply, understanding these carefully, and seeing like what actually would be required to ensure that this type of information or related information isn't kind of leaked through model responses. But to me, really I would say the very, very first thing that has to be done is actually like some joint effort in agreeing like what are the values, and like what are the priorities, and what is like actually unsafe, not unsafe. You know.
Awesome. Yeah. Thank you so much for the wonderful talk, David. As you can see, there's a lot of interest in your work in the community. So if you ever have a future work you want to present, you have my email. And yeah, thank you so much for your time.
Thank you. Thank you for inviting me.
Okay, we'll end the session here. Thank you, everybody, for joining, and we'll see you again in 2 weeks. Bye.